Welcome back to Nature of Code in Rust and GGEZ. Today we're going to be going over exercise 1.6. Referring back to the introduction, implement acceleration according to Perlin noise. All right, well, if we remember from last time, we have acceleration being set randomly every single frame. So this is going to be relatively similar, but at the same time, we need to be Perlin noise that's randomly created. So I'm no longer going to use the random 2D, or I guess like the random vector function or method off of vector 2. Instead, we're going to have to sort of like deal with that on our own. So if I want to, I probably want to store Perlin itself up here. So we can have like maybe our Perlin RNG, and this is going to be a Perlin. And then we're going to have an X off and a Y off. So we can have a Perlin X off, which is a F64, and a Perlin Y off, which is also an F64. And then we're going to use that to set the acceleration early on. So let's go ahead and set these ourselves. So Perlin RNG, you're going to be a Perlin new. We're going to have the Perlin X off and Y off. I don't really necessarily think it matters if they're the same or different. I've been making them different. Let's have them be the same, sort of like see how that works. So let Perlin X off is equal to 0.0. Perlin Y off is equal to 0.0. And then we're going to have an update by. So let's have that update U2. So we'll have a Perlin. What is this going to be? Increment. So increment, and we're going to make this a F64. Perlin increment, and you're going to be 0.01. And let's go ahead and store these away. So we have Perlin RNG, Perlin X off, Perlin Y off, and Perlin increment. So then in update, we're going to be setting acceleration to a new vector with that X and a Y. So we're going to do, let's see, how does it work? It's let letter X is equal to self dot Perlin RNG dot, it's get, and then we have to give it a new point, which I think can just be an array of self dot Perlin X off, self dot Perlin Y off. And that's going to give us the X64 for X. And then we're going to want to do the exact same thing for the Y. Something I notice here is we need them to be different numbers. So I can't use anything. I'm going to want Perlin X off. You know what? We're going to want this to be, this could be a vector. I think this could be a vector. So we can have a Perlin X off. It can be a vector too. But you would need to be an F64, and I just removed that from. I just removed those from having generics. So I don't know if I necessarily want something in here. So maybe I do need to be like, oh, okay. So Perlin X off. I'm going to make this be an array of F64, 2 of them. And then Y off is also going to be an array of F64, 2 of those. Increment is still going to be an F64, so it's a little bit extra work here. And then when we create these, we're going to start with 0.0, 0.0. And then I want you to start with maybe something like maybe 10,000. And that will be our X off and Y off. So we have our purlin X off and our purlin Y off. Okay, so I think that this is going to work. Then when we get the X, we can just pass in self.purlin X off here. And then we do Y is equal to self.purlin RNG, get U, and this is going to be self.purlin Y off. All right. So now we have a completely random X and Y that are not going to be the same at all. So we can create our acceleration is going to be new based upon this X and Y. Now these are a number between 0 and 1, so multiplying to scalar should be fine too. We could normalize it as well. That might actually help it feel a little bit more accurate, more, I don't know what the right word for it is. Basically, by normalizing it, we're going to make sure that it's not going to move like a really super small amount. So I'm going to say self.acceleration. We're going to normalize that. Then we're going to scale it up. All right, so we have that. Now at the end here, and we couldn't just do this right after we get our X and Y. Let's not forget to increment the points here. So we're going to say self.purlin X off. I can't just like add to it because it's an array. So of position 0 plus equals self.purlin increment purlin X off of 1 is equals self.purlin increment. And we're going to do this for purlin Y off of 0 is equals self.purlin increment, and then Y off 2. So that should ensure that it's not exactly the same every single time. Oh, and I almost forgot that these need to be cast into an F32 as F32. All right, let's go ahead and give this a shot, see how it looks. We don't have an error, but you're not showing up on screen. So what's going on? Did you move too fast? Or is something else going on here? We're creating this. We ran you. Our acceleration gets multiplied and then added to velocity. So that should be right. Let's go ahead and debug this acceleration. Make sure it's what we think that it is. So we see here, oh, it's this really small number. So we can see like, okay, X is 0.5, Y is negative 0.2. So we are doing this for acceleration. We're not like updating location by accident. So that's getting our X and Y as purlin noise. We see that it is positive and negative. So self-acceleration equals a new vector. We normalize it. We multiply it. So if we debug down here, on one, we debug down here, we should see what this acceleration looks like. Let's go ahead and run this. We can see that it's sometimes 0, sometimes negative, going to like y is 2 or so. That seems to be appropriate. Okay, so then self.velocity. We have u as a 0, 0. Mesh. Okay, so we're creating this with a mesh with our actual mesh. Okay. And we're not getting rid of that, so it's still drawing out. In our main library, we're calling update and check edges. That should work. I'm going to go ahead and pause this video while I try to figure out what exactly is going on. And as soon as I figure that out, I'll unpause. All right, I'm back. I just found a really big problem here. So I was trying to decide, like, is there just no mesh? Is that the problem? Well, it turns out that my location is a problem. I ran a debug self.location here, and I'm seeing that location is not a number at this point of time. So, well, that's a problem. So let's just move it up and find out, okay, how about this velocity? If I run this, velocity is also not a number, okay? Let's just keep on moving upwards until we find out what is it no longer a number. My guess is there's a problem around here somewhere. So not a number anymore. Oh, you know what I bet it is? I bet sometimes acceleration is a 0. Well, let's find out. Let's keep on going up. Now we're going to look at acceleration. So we saw in my like debugging before that we were getting an actual vector 2. So that was working. Negative 0, that. When I normalize, so if I don't normalize this, I think it's going to work. Yeah, it works. Okay. So normalization is a problem here because if the magnitude is 0, then we attempt to divide by 0, and that's kind of not allowed. So we want to go into our vector2 utilities here and ensure that that just is never a problem. So let's go find magnitude. Let's just go ahead and check here if how would we know to do like that it would be 0? It would be, oh, it's normalize. If, where's our normalize method? So random magnitude limit to array normalize here. Okay, so if magnitude, there's no is 0, right? There is. Okay, so if magnitude is 0, we want to early return. We don't want to actually do anything else. So if I do that, we head back to our mover. I should be able to remove this debug, and we should be able to normalize you again. So if we run this again, now everything works fine. So that was the problem, is we needed to update our magnitude in order to handle 0 case. I believe I had that before, but in the rewrite of the vector2 struct, I sort of forgot to handle that case again. And we ran into a problem where that existed, and we had to debug to figure out what was going on. However, that was exercise 1.6, which is implementing the movement via Perlin noise. I'll see you in the next video. Thank you very much. Bye.